Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the project you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode, today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, then don't miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, Corinium Global Intelligence, and Data Council. Upcoming events include the O'Reilly AI Conference, the Strata Data Conference, the combined events of the Data Architecture Summit in Graph Forum, and Data Council in Barcelona. Go to dataengineeringpodcast.com/conferences to learn more about these and other events and take advantage of our partner discounts to save money when you register today. Your host is Tobias Macey, and today I'm interviewing Benn Stancil, Chief Analyst at Mode Analytics, about what data engineers need to know when building tools for analysts, and just full disclosure that Mode is a past sponsor of this show. So Ben, could you start by introducing yourself?
So my name is Benn Stancil. I am one of the founders and chief analyst of Mode. Mode builds a product for data analysts and data scientists. So I'm responsible for both our internal analytics here at Mode, as well as working a lot with our customers to help them better understand, or help us better understand the needs that they have in the product and how we can better serve them as analysts and data scientists. And so prior to Mode, I worked on the analytics team at Yammer, which was a startup that was purchased by Microsoft in 2012. And before that, my background is in economics and math. And so I actually worked for a think tank in DC for a few years, doing economic research before landing in San Francisco and in the tech world.
And do you remember how you first got involved in the area of data management?
Yeah, so it was actually as a customer, really. So I was working as an analyst at Yammer. My first job in tech was at Yammer. And I was really a customer of our data engineering team. So we used the tools that they built as well as the data that they provided. So Yammer was kind of one of these early leaders in the philosophy that engineers shouldn't build ETL pipelines. Which is now something that's become a little bit more popular. There's a blog post from the folks over at Stitch Fix that talked about this very explicitly. But Yammer had this same philosophy. And so while I was there, we were responsible for building our own pipelines and for sort of dipping our toes into the data engineering and data management world. And so that was kind of my first taste of it. Then after leaving Yammer and starting Mode, which I've mentioned is a product for data analysts and data scientists, I actually ended up taking kind of two further steps into data management. First, I'm responsible for our own data infrastructure here at Mode. And so my role is to think about not just the analytics that we do, but how we actually get the data in the place that we want to get it. But also, in a lot of ways, Mode is serving the same problem or providing the same service that the Yammer data engineering team was providing me when I was an analyst. Which is we are now building tools for other data scientists. And so the product that we provide, we very much have to think about how does it fit into sort of the data management ecosystem? How does it solve the problems that not just analysts and data scientists have, but the problems that data engineers have when they're trying to serve those customers.
And so you've mentioned that at your work at Mode, you're actually responsible for the data management piece and that you're working closely with other data engineering teams and other analysts to make sure that they are successful in their projects. And I'm wondering if you can start by describing some of the main features that you are generally looking for in the tools that you use and some of the top-level concerns that you're factoring into your work at Mode and the tool that you're providing to other people.
Yeah, so internally at Mode, one of the things that we really care about is we want to make it something that is easy to use for the analysts and data scientists who are actually consuming that data. So again, kind of go back to the point from that Stitch Fix blog post. We really believe that the data scientists here at Mode should be responsible for as much kind of data management as possible. That there's a lot of great tools out there now that are ETL tools or warehouse tools or pipeline tools that analysts can manage pretty well. And you don't actually need someone to be kind of a dedicated capital E engineer to really build out the initial phases of a pipeline. And so for us, when we evaluate those tools internally, we want to make sure that they're things that we can set up pretty easily, and they're things that as customers of those tools who aren't necessarily the sort of, again, fully fledged engineers ourselves, we still know how it works and can still make sure that it's up and running and performing the way we want. I think the analogy we often use with this is it's like buying a car that you don't necessarily need to know the ins and outs of how the car works, but you need to know that it's reliable. And if you learn to not trust the car, that it's not actually going to drive when you want it to drive, you don't want to actually learn how to fix the car. You just want to buy a different car that actually works. And so when we're looking for tools ourselves, we tend to focus a lot on that, on like, what's the experience like for the folks who are using it? Can we rely on it? And is it something that we need to have a dedicated person to run, or is it something that we can kind of run in the background and the analysts and data scientists can get it to work the way they want it to work? The other thing I think that we really look for is usability. So I think this is a place where ETL tools and data pipeline tools, the folks who are building them often don't think about as much as perhaps they could, which is the surface area of those tools isn't the application itself or the web interface. I really think of the surface area of those tools as the data itself. That if I'm using an ETL tool, the way that I interact with that tool day in and day out is by actually interacting with the data that tool is providing, not by logging into the web interface and checking the status of the pipelines and things like that. And so in those cases, little things matter. It ends up being column names that matter, like are there weird capitalization schemes or are there periods in column names? And those little things that make it more frustrating to work with that day in and day out end up being the things that really drive kind of our experience with those tools. When we're working with customers, and so most customers range from being small startups to much larger enterprises. I think for small startups, they often look like us. For the large enterprises, the place that we really try to focus is making sure that the tools that we recommend are modular. That data stacks end up becoming very complicated. They end up having to serve a lot of different folks across a lot of different departments, pulling data from tons of different sources. We try to avoid people focusing on like one tool to rule them all. This kind of having one pipeline, one warehouse, one analytics tool, all of these things serving every need, I think is often it sounds nice, but it's often very difficult to actually create that. And we'd rather people be able to kind of modularize different parts of their stack so that if something new comes along that they want to use, they can easily swap something else in and out without having to kind of re-architect the entire pipeline.
A couple of things that came out at me as you were talking there are, one being that you're talking a bit about some of the hosted managed platform tools where anybody can just click a button and have something running in a few minutes. And then on the other side of the equation, particularly if you have a very engineering heavy organization or a larger organization, you're probably going to be having dedicated data engineers building things either by cobbling together different open source components or building something from scratch. And I'm curious what you have found to be the juxtaposition as far as the level of polish and consideration for user experience of the analyst at the other side of the pipeline as you have worked with different teams and different tools that fall on either side of that dividing line of the managed service versus the build your own platform.
So the managed service, it depends on the tool. I think some tools do a really great job of this, some tools less so. I think it's probably true for any products in a similar space. Some products do a really great job of thinking about the experience for customers, and others are more focused on technical reliability or more focused on other aspects of that product experience. I think that for an example of one place where I think like there's a great tool that focuses on some things that work really well, but also has one of these pain points. Snowflake, for instance. So we're actually Snowflake customers. The database, it's a very powerful tool for us. We recommend it to most anybody. But they, I believe, in the tradition of the Oracle folks from which it came, all of their column names are automatically capitalized. And so it's just one of those small irritations that it seems like when they developed it, it wasn't necessarily a consideration of how are analysts going to be interacting with this day in and day out, when all of your queries are constantly yelling at you because you have to capitalize everything. So little things like that, I think, are places where companies could think a little bit more about the ways that people use it. From the perspective of internal tools, and the folks who are building these from scratch, I actually think in a lot of cases, those tools tend to be better in the ways that they think about user experience, because the people who are building them are sitting directly next to the customers that they're providing it for. That if you're an engineer and your customer is the desk over from you, all of those things, there's like a really fast back and forth between, oh, how do you actually use this? You see someone use it every day. You hear them complain about it. They get the benefit that vendors don't get of literally working with their customer day in and day out, and their customer being able to like walk over to their desk and say, hey, this is a thing that can you change, and stuff like that. So while the internal tools often aren't as technically robust and often aren't as reliable in a lot of other respects and aren't nearly as powerful and flexible, the small things often work a little bit better because they were custom built for exactly that audience.
For the things that you're talking about that contribute to just an overall better experience for the analyst, things like managing the capitalization of column names or preventing the insertion of dots in the column name that will break a SQL query, what are some of the guardrails that data engineers should be thinking about in terms of how their tools are able to generate specific types of output, or the overall ways that they can be thinking of the end goal as they're building these different tools and pipelines that would make it easier for analysts and other people within the business to be able to actually make effective use of the end result of their work?
Yeah, I think it's being a product manager in a lot of ways. It's doing the research and knowing your customer. That those little things aren't things that are necessarily going to be obvious, and it's very difficult to sort of build a framework to show you exactly how those things will work. I think the best framework is the frameworks that product managers or designers build of how do you understand the needs of your customer, how do you engage with your customers and learn from them. That, you know, even as an analyst and as someone who lives in these tools day in and day out and is the customer of those in a lot of respects, I don't know that I could sit down and make a list of here's all the little things that I like or don't like. It's something that you very much realize as you're working on it. In the same way that I'm sure for engineering products or tools that are built for engineers, they have opinions about how those should be built, but don't necessarily have like an ability to just write down this is the framework for understanding all these things. I think a lot of it is wanting to build something that your customers like, and then taking the time to listen to them and understand sort of what are these pain points they're having and where do they come from? Like why, what are you trying to accomplish when you do it? I think a lot of it is sort of the fundamental aspects of product management and sort of user research to really get at the core of what those problems are.
From the perspective of a team dynamic or an organizational approach to managing these data projects, how much responsibility do you feel lies with the data engineering team to be able to ensure that they're considering these end user requirements as far as the capitalization of schema names or things like that, when they're also concerned with trying to make sure that they're able to obtain source data? They want to make sure that their pipelines are reliable and efficient, and they have, maybe N+1 different considerations for the overall management of the data itself before it gets delivered, and how much of it is a matter of incorporating analysts in that overall workflow, basically just trying to get the breakdown of where you see the level of understanding and responsibility for identifying and incorporating these UX points in the overall life cycle of building these products.
So generally I would say like the tool needs to work in the other respects and recognize that a lot of the data engineers that are building these products, or either internally or as vendors, there's lots of very complicated problems that they have to work on. And I think most analysts would recognize that as well. I think the responsibility doesn't necessarily lie for the engineers building these tools to go out and determine all this stuff on their own and not get the help of their customers to be able to tell them to do that. I think that the thing that is the responsibility of the tool builders is more just having the empathy of the customer that's using it. That it's less about, I need to go figure out what are these little things, these usability issues or other things like that are going to be the things that get in the way of my customer using this every day. They should be sort of more just willing to listen when somebody has that feedback and recognize that those sorts of things are also things that will affect how somebody uses the tool that they build. So I think, you can't, again, as with any product, I don't believe you can build something that's a technical marvel if it's not something that people want to use. There's plenty of examples of tools and companies that have done this and have focused on, if I build this monument to some technical expertise, then people will come use it. Well, not really. Like people will use it because it helps them solve a problem. And while you need to be able to figure out a way to balance those two things, I do think there's some empathy to the customer that's necessary there of what is it that makes you want to use this thing every day. Yep, all of the sort of upstream technology that requires it is very important. Obviously, if there's super organized and super clean and super sort of well-defined data, but there's not any data in there because nobody actually was able to get the data from the source into the warehouse or whatever. Obviously, nobody's going to use that either. But I think it's important to keep in mind that usability matters, and you have to have the empathy for your customers as you're building those products.
And ultimately, from the few things that we've brought up as examples, they're fairly small changes that don't really include any additional technical burden on the people building the pipelines. It's just, as you said, a matter of empathy. But from your experience of working with other data engineers and with your customers and different data teams, what are some of the common points of contention that you have seen arise between data engineers and data analysts as far as how they view the overall workflow or life cycle of the data that they're trying to gain value from?
So yeah, the examples were simple ones. I think there are places too, especially this happens more, I think, in the internal use cases, where there are more complicated things that are, an analyst is trying to frequently solve a problem in a particular way, and maybe they want better mapping software or something like that, because that's a way that like execs often ask questions and they just want a quick way to be able to visualize something on a map, but rather than having to format it in a particular way and load it in a Tableau and do that. And so there may be more complicated things there, which I think is again kind of a product question for the data engineers rather, to figure out how hard is that to build and how much value is it really providing, and understanding again kind of the use cases behind the request. In terms of these like sort of points of conflict or where people can align, I think one of the things I think that's really important is for data engineers to understand how data scientists and analysts think. That again, it's really understanding your customer, but it's not just understanding, I need to be able to deliver dashboards to executives and answer these challenging questions. It's understanding kind of who your customers are and where they come from. And I think there's a couple like big things that are sort of define a lot of analysts that I think are like critical for thinking about how you build tools for them. One is they're trying to solve problems like quickly and often trying to answer questions quickly and in rough ways, that they'll get a question from an exec that's like, why is this marketing campaign not working? And they're not trying to necessarily answer that scientifically. They're trying to turn around something so that the business can make a decision. And to an engineer or to a statistician or to somebody who's focused on building robust tools, the way that an analyst works may look sloppy. It may look like something where they're not crossing T's, they're not dotting I's. They're very quickly trying to do something rough and sort of hacking their way to a solution. But in a lot of cases, that's the whole point. Like, that is the value of what an analyst does is take complicated questions, distill them down to something pretty quick, ship it off to somebody who's making a decision and help the business make a decision and move forward. And so in a lot of ways, I think the ways that the tools get built and the ways to sort of remove friction are to understand not just the problems they're trying to solve, but the kind of mindset behind it, which is this, all right, I have a question. How do I answer it? How do I draw conclusions from these observations? It's not how do I build a logical model? How do I build sort of the most mathematical thing possible? How do I abstract a complex system? It often feels kind of rough and sloppy, but to an analyst, that's the job.
And so far, we've been talking about the API between data engineers and data analysts as being the delivered data, probably sitting in a data warehouse somewhere. But on top of that, you've also built the Mode platform, and there are other tools such as Redash or Superset that exist for being able to run these quick analyses and be able to write up some SQL, get a response back, maybe do some visualization. I'm wondering, as far as the way that you think about things and also the way that you've seen customers approach it, where the dividing line is in terms of the platform and tooling that data engineers should be providing versus where the tooling for being able to perform these rapid analyses lives in terms of who owns it and who drives the overall vision for those projects.
Yeah, so I think that kind of has to be a joint effort. One of the failure modes here, I think, can be just kind of throw it over the wall. You build the tools, I'll consume the tool. Where these two teams aren't tightly synced. That I think it's important for them to be able to sort of have similar focus on the same problems. That that it's not just for, like, data engineers shouldn't just be thinking about my objective is to build a tool. I'm a believer that data engineers should sit very closely to data scientists or data analysts and should basically have the same KPIs. The objective should be, how do we answer the questions we as a business need to answer? And a data engineer's job is to enable that. Their job isn't to say, like, all right, I've hit my KPIs because I delivered a tool. They should be trying to serve the same needs as the data scientists. And so I think it's, if you end up with the kind of, okay, we'll build a tool and somebody else will take it and consume it, I think you end up with this disconnect where the analysts aren't able to actually, like, deliver the quality analysis they need to deliver. And there ends up being a lot of friction at that like touch point between the two, because analysts are looking for a particular thing. They come back to the data engineers and ask for it. Data engineers, feel like they're being sort of told what to do. You want to be able to allow these groups to be a little bit more autonomous. And I think the only way you can do that is allow them to be invested in the same result. So it's enabling engineers to understand, like, what is the value of their product, not just to the analyst, but how does it provide value to the broader entire users around the company. And so in cases like Superset, I think if I'm a data engineer building, implementing Superset at a company, I would want to understand not just, okay, great, they want Superset plugged into this data. It's, what questions are you trying to answer to that? At what frequency do you need to do it? Who's the customer of those questions you're trying to answer? All of those things help drive some of the decision making behind, how do I get it up and running? Is it something that everybody needs to have access to? Is it something that just analysts need to have access to? Is it something that needs to be shared easily? There's a lot of work there, I think, that is in this gray area between the two. And I think those two groups need to be, like, open to that gray area rather than sort of perfectly defined. You work on just these things, I work on just these things.
Yeah, in some ways it's changing the definition of done, where in one world, the definition of done for a data engineer is, I've loaded the data into the data warehouse, I've washed my hands of further responsibility, it's now in somebody else's court, versus the definition of done is, I was able to get the data from this source system all the way to the chief executive who needs to be able to use the resulting analysis to make a key decision that will drive our business to either success or failure, and aligning along those business objectives rather than along the sort of responsibility objectives, which is one of the recurring themes that's been coming up a lot in the conversations I've had on this show, as well as a lot of the themes that have been arising in the division between software engineers and systems administrators that led to the overall sort of DevOps movement, and just a lot more work in terms of aligning the entire company along the same objectives rather than trying to break them down along organizational hierarchies.
Yeah, I agree. And I think, like, one, this is a kind of, again, getting back to some small details, but one example of this actually comes to mind where this broke down was, it had a team, like a data engineering team, that was very much focused on loading data into a warehouse, an analytics team that was responsible for, like, taking that data and passing it off to somebody else and answering questions with it. And there was, like, a column name, and I believe the column name was updated at, because I think that's, like, it's just like a system table that, a lot of, like, Rails apps and things like that have updated at timestamps that are system generated. That was put into the warehouse because that was what it, it was, to an engineer, it made perfect sense. They put it in there. It was like, it's clearly named, all of that. To an analyst or data scientist, they interpreted that to mean something different without the kind of, like, understanding where they were trying to go with the problem downstream from it. It was like a clean handoff that to both sides was like, updated at. I know exactly what that means. Both sides thought they knew exactly what it meant. And then they ended up creating these analyses on top of that with the assumption that column means something that it didn't mean. And just by having this, like, okay, you take the ball, you run with it, and I'm sort of, like you said, wash my hands of it, it ended up driving sort of a very bad result. And so that problem that could have been fixed very easily, but because the team wasn't focused on kind of the end result of the business objective, the data engineers never actually saw the analysis that was being produced. They never really understood the questions that were being asked. They assumed, okay, you're using it the way you should be using it, instead of stepping back and saying, like, all right, let's kind of work on this, the actual problem together to make sure that we're solving this problem in the right way.
This is where another one of the current trends comes into play, of there being a lot more focus on strong metadata management and data catalogs, and being able to track the lineage of the data so that you can identify, oh, this updated at column wasn't created for the data warehouse. It actually came from the source database. And I understand now a bit more about the overall story of how this came into play, versus having these very just black box approach of, all I know is this is how it is now. And then also in terms of metadata management, being able to know how frequently is this data getting refreshed? When was the last time it was actually updated in the data warehouse versus whatever this updated at column is supposedly pointing to that I'm potentially misinterpreting.
Mm-hmm. Yeah, and I have a somewhat negative view of documentation on these things. I think that is a noble goal, but it's really hard to maintain. That if you have sort of manually created documentation with sort of data dictionaries where people write down, this column means that and stuff like that, it's often really hard to keep that up to date. Like, people are now adding data sources so quickly, data's evolving so quickly that often will lag. And in a lot of cases, a data dictionary that's out of date is more dangerous than no data dictionary at all, because people will go to it, be like, oh, here's the data dictionary, I assume that this is correct. And it's actually a month behind where it should be. And so people are confidently making a decision off of out-of-date information rather than looking at it with a little bit of skepticism. This is actually, in my mind, a problem that hasn't really been solved. I know there are some vendors out there that are attempting to do this. What's the company called? I'm now blanking on the name, but there's a company that's attempting to do this through kind of using the patterns of how people are actually using data to document it, sort of this automatic documentation that happens in the wake of usage rather than people having to manually create it. I think that's, whether or not that technology works sort of remains to be seen, but I think that is the right way to think about documentation, where documentation is really a product of the way that people use something. And really, the way that when I have joined teams or had new folks join teams, the best way that they learn about how different pieces of the data sort of schema works, or like how things are connected together, is often from seeing how problems have been answered by other people and mirroring that. It's like documentation based on actual usage and documentation sort of centered around the ways that people define concepts, rather than documentation based on some giant Excel file that is like, this column is of this type with this data. There are a few folks I've seen that pulled that off, but for the most part, it just becomes a huge time sink to invest in it, and something that almost always ends up lagging. So that is a tricky problem. I think that's something that over time folks may figure out, but definitely one of those things that for now has to be a little bit of, we learn by doing rather than we learn by reading a manual to know exactly what these things are. There probably are some places where you could include sort of like a common pitfalls type of thing of like, don't use this updated at timestamp, or this thing it says month to month, but in reality it's not. Don't trust it. Those sort of little like gotcha kind of things. But like a broader documentation is something that we haven't seen anybody implement terribly well to this point.
I definitely agree that the idea of the static documentation, as far as this is where this comes from, this is how you use it, is grounds for a lot of potential error cases because of, as you were saying, it becoming stale and out of date and no longer a representation of reality. I was actually thinking more along the lines of the work that the folks at Lyft are doing with Amundsen for being able to use that for data discovery and having a relevance ranking as far as how often it's being used, or the work that WeWork is doing with Marquez, where they're integrating a metadata system into their ETL pipeline so that it will automatically update the information about when a table was last loaded from source and what are the actual steps that a given piece of data took from the source to the destination, where you can look up the table in the data warehouse and then see what are the actual jobs that brought it there and when were they last run and were there any errors, to be able to get a better context from the end user perspective as far as what was the path that this data took, so that I can have a better understanding about where it came from and how I might actually be able to use it effectively.
I think those are super interesting projects. And there's recently a company called Elemental released an open source tool called Dagster that kind of follows in that same pattern of trying to make pipelines that look a little, you're able to sort of parse your way through them a little better and diagnose kind of, oh, this thing went from step 1 to step 2 to step 3. And I think that stuff I think can be super interesting for analysts and data scientists, because one of I think the big missing pieces in data stacks, and it's maybe solved by these, maybe not, is if I'm working on a question, or if I get asked a question, I'm sort of investigating some data and something looks awry, like something doesn't quite look right. There's always a little bit of the back of my mind that makes me think, I wonder if this is a data problem. And you're never able to quite escape that. And part of the reason I think that's true is like pipelines are notoriously fragile. You're always going to like miss some data. There's always little things that you you have to go through this process of like, this result doesn't quite make sense. I wonder if I'm double counting something because this one-to-one mapping that I thought was in place actually isn't, that something got written in a way where we thought we had, one Salesforce opportunity per customer, but it turns out a second one got created somehow. And you have to kind of go through this sort of down this rabbit hole of checking your data in various ways. It's not just like, was it loaded properly, but all of these other like unit test type of things that I don't know necessarily how you quite avoid it. There are probably technologies to build to help a lot with that, but there's nothing really in place that gives an analyst or a data scientist, once they look at something, full confidence that, yes, this is something that I understand. I know exactly what it is, and I need to investigate the business part of the problem that this data is telling me, rather than, well, should I like check and make sure everything is working before I go too far down trying to understand why the thing happened that I think may or may not have happened. And so any step to me that moves in that direction, whether it's Amundsen, whether or not it's the thing that folks are building, whether or not it's the sort of unit test type of tools that DBT has built, all of those things I think that provide a little bit more confidence in. I can now check off some things on the list that I was going to have to go check to make sure things are right. The faster you can get through that, the faster as an analyst I can focus on, again, solving the business problem rather than kind of banging your head against like, is it a data problem? Like, what do I not know before I want to go take this to an executive and say like, oh my God, look, our revenue is doing great this quarter. And then the last thing you want to come back is be like, well, you actually had a data problem. And that thing that I told you wasn't true because I failed to investigate this one pipeline that did a thing that I didn't expect.
That's actually a great point too to be made as far as the relationship between data engineers and data analysts, and ways that data engineers can help make the analyst's job easier is actually making sure that they are integrating those quality checks and unit tests and being able to have an effective way of exposing the output of that, as well as incorporating the analyst into the process of designing those quality checks to make sure that they are asserting the things that you want them to assert. So in the context of the sort of semantics of distributed systems, there's the concept of exactly once delivery, or at least once delivery, or at most once delivery, and then understanding how that might contribute to duplication of data or missing data, and what are the actual requirements of the analyst as far as how those semantics should be incorporated into your pipeline, and what should you be tuning for, and how are you going to create asserts, whether it's using something like DBT, as you mentioned, or the Great Expectations project, or some of the expectations capabilities that are built into things like Data Lake, and then having some sort of dashboard or integration into the metadata system, or a way of showing the analyst at the time that they're trying to execute a query against a data source, these are the checks that ran, these are any failures that might have happened, so that you can then take that back and say, I'm not going to even bother wasting my time on this because I need to go back to the data engineer and tell them this is what needs to be fixed before I can actually do my work.
I very much agree with that. And I think that there's a lot of time gets sunk into, there's the common lines of like data scientists spend 80% of their time cleaning data and all that. I think that number obviously varies a lot. And for folks who are using machine generated data, if you're using data that's event logs and things like that, you don't spend that much time cleaning data. Like machine generated data is not particularly dirty in the sense of, I have to, clean up a bunch of political donation files that are all like manually entered. Like that's dirty data where you have to figure out a way to take these 50 addresses that are all supposed to be the same and turn them into one. But machine generated data doesn't have that problem, but it has a problem of, can I rely on it? Like, did it fire these events properly? Did it fire them 10 times when it was supposed to fire them once? Did it miss a bunch? And so anything I think that, can help sort of that cleaning problem of understanding exactly what I'm looking at and how much does my data represent the truth is something that you always, again, as an analyst, you always have this in the back of your mind that like, this isn't quite truth. This is the best we have. And in a lot of cases, I think it's close, but I always have to be a little skeptical that it is truth. And so the pieces there that can help are a big value. Another thing too, that I think actually data engineers can do a lot for analysts and data scientists as well is like, engineers have solved a lot of these problems or have thought about solutions for solving these problems in ways that folks that come up through sort of the typical channels into being an analyst or data scientist haven't. So like one of the interesting things about data scientist roles is people come from all different backgrounds. Like you'll be working with someone who's a former banker who is super deep in Excel, but is just learning SQL. You'll be working with someone who's a PhD, who's written a bunch of R packages, but has never actually used a production warehouse. You'll be working with someone who's a former front-end engineer who got into data visualization. You'll be working with like an operations specialist who's been writing Oracle scripts for 10 years. Like, there's no consistent skill set for where these folks come from. And so the idea of even writing something that amounts to a unit test or writing something that lets you, the concept of version control and Git are also things like those sorts of concepts aren't things that are necessarily going to come naturally to folks in analytics and data science. And so I think there's places where data engineering can kind of push some of those best practices onto the ways that analysts and data scientists work. And I think this is data engineers can do it, vendors can do it. There's lots of different ways that we can sort of standardize some of that stuff. But there's definitely those sorts of practices, I think, that can come from the engineering side of kind of this ecosystem to really encourage folks to be able to learn those things, or folks to be able to push in that direction to learn some of the pieces there that are valuable for their jobs.
Another element of the reliability and consistency aspect from the analyst perspective when working with the data is actually understanding when the process of getting that data has changed. So you mentioned things like version control. So if I push a release to my processing pipeline that actually changes the way that I am processing some piece of data, and then you run your analysis and all of a sudden you've got a major drop in a trend line and you have no idea why, you're going to be spending your time tearing your hair out of maybe I did my query wrong, or maybe something else happened, and just being able to synchronize along those changes and making sure that everybody has buy-in as to how data is being interpreted and processed, so that you have that confidence that when you run the same query, you're going to get the same results today, tomorrow, and the next day. And then all of a sudden, when that expectation is not met, you start to lose trust in the data that you're working with. You start to lose trust in the team that is providing you with that data. So just making sure that there is alignment and effective communication among teams for any time those types of things come into play, I think is another way that data engineers can provide value to the analysts.
Yeah, like as a very concrete example of this, and that trust, I also think it extends further. And I think there's if as a data engineer, again, if your goal is to build an organization that's focused on the products that you're building, or that has the mentality like the products you're building matter, you also need to think about that. Because so as a concrete example of that, say you have like a revenue dashboard, and revenue at companies, we've worked with a lot of companies, like figuring out how much you make, it seems like it would be the simplest thing. It's like one of the most important numbers any company has. It's always impossible. Nobody does this well. It's always like there's a ton of these weird edge cases, data coming from tons of different places. It's coming from a billing system. It's coming from Salesforce, which is all this manually entered stuff. So it's this kind of nightmare of a process to just figure out like how much money did we make. But say you have like a revenue dashboard and it says today that you made $1 million last quarter, and then tomorrow it says you made $1.5 million last quarter. And as like an analyst, that's your nightmare scenario, because now an executive saw this, they don't know which number's right, they're mad at you because why in the world did this thing change? They just told the board it was $1 million, and now it's saying $1.5 million, and like, is it going to go to 750 tomorrow? And nobody's going to know what happened. And so you end up having to dig through so many different pieces of that. It's like, did you write a bad query? Did a sales rep go into Salesforce and like, oh, they backdated a deal that actually signed? Was there a data entry problem in Salesforce where somebody put in something wrong? Did you double count something that you didn't mean to double count? Was there a data pipeline problem where data got updated in a bad way? Like, all of those things end up becoming just this, all right, how do I figure out what happened? And often you don't have any real record of what the system was before. You just know it used to say $1 million and now it says 1.5, and you're like, I have to figure this out. And those are the types of problems that are the headaches for data analysts, and the ones that you end up finding yourselves in all the time. And the more systems that you could have in place that let you say, oh yeah, it's 1.5 because we backdated a deal, or because this other thing happened. The faster you can answer that, the easier your job is, but kind of more importantly, the more trust that the rest of the organization will have in your job, because you're not spending all this time trying to like explain a number and not sure which one you actually want to stand behind.
From the perspective of somebody who is working so closely with data analysts and with companies who have data engineering teams, as well as consuming some of these managed services for data platforms, I'm curious what you have seen in terms of industry trends that you're most excited by from your perspective as an analyst, and some of the things that you are currently concerned by that you would like to see addressed.
Mm-hmm. So I think that we've seen like, this isn't really a technology, but I think it's in one of the places where the business sort of industry can go, that generally industry has made like very big strides in enabling kind of day-to-day data-driven decision making. That we've done a lot about, how do we get data in front of people around the business? How do we get it to them quickly? How, when I am making a decision as a sales rep of who do I call today, or a marketing manager, which campaigns do I focus on? How do I do that? Like, how do I make that decision? And I think we've made a lot of progress in that front. One of the places where I think we nailed as an industry can sort of start to turn and focus more on is businesses aren't driven by these daily optimizations. And businesses don't win because they made the right daily optimizations. It certainly helps, but the big bets are often the things that determine the winners. Like Jeff Bezos has this line that in business, you want to swing for the fences because unlike in baseball, where the best you can do on a single swing is score 4 runs, in business, if you take the right swing, you can score 1,000 runs. Like there's such a long tail of positive outcomes from decisions that it's worth it to take some big bets and make these big bets because the outcomes of those can be sort of way better than any kind of like small optimization. And I think that we haven't really had data technologies that's focusing on people figuring out how to make those big bets. There's a lot of like exploratory work that analysts do to really try to understand like what is the big bet that we should make. And I think that's one of the places that I'm excited for folks to be able to go next, is not just, all right, we are data driven because we have dashboards. We are data driven because everybody's able to look at a chart every day. But how do we become data driven about the big bets? How do we become, and that I think is really, how do we enable data analysts and data scientists to answer questions more quickly, to be able to explore which big bets work out? Like ultimately the way that I think you win on making big bets is by being able to make more of them and making them smarter. And so the way I think you can do that is basically like more quickly research these problems and understand what might happen if you make these changes. And those aren't things that a dashboard will tell you. Those are the things that like in-depth analysis will tell you. And so I think, as an industry, I think that's a lot of one of the places we can go next, is not just enabling, again, the how do we optimize small things, but how do we like uncover the really big opportunities that are still very much kind of in a boardroom type of conversation these days.
And are there any other aspects of the ways that data engineers and data analysts can work together effectively that we didn't discuss yet that you'd like to cover before we close out the show?
I think it mostly stands behind knowing your customer and knowing the problems they're trying to solve. That it's really getting into knowing exactly what it is that they're trying to do and how they use the products that you build. That again, this is, I think, learning from engineers, or not from engineers, excuse me, from product managers and designers is a super valuable thing because that's the problems they solve is learning from their customers. And I think that data engineers can in a lot of ways do the same thing. One other thing that I think is a place potentially where data analysts or data engineers, and this isn't really necessarily data engineers, but a place where organizations can think a little bit about data engineering today, is don't hire folks too early. Tristan Handy, I think it was Tristan, wrote a blog post about this that was basically focusing on this idea that a lot of organizations will think they need a data engineer before they do. And with all these tools out there now, with the ETL tools, with sort of point and click warehouses that are super easy to set up, with how well these tools scale, that Stitch and Fivetran and those sorts of tools can scale to pipelines that are plenty big for most companies. Snowflake and BigQuery and Redshift can scale to a database that is plenty big for most folks. It's like your data engineering problems are often not going to be that interesting or complex. They're problems that having someone who owns is important, but they often don't need to be someone who is a dedicated data engineer. And I think there is a way in which companies can like hire for a data engineer too quickly because they sort of a role they think they need, but the data engineer ends up basically being an administrator of a bunch of third-party tools. And that's not a role that a data engineer wants. A data engineer wants to solve hard problems. They want to be able to work on interesting stuff. They don't want to be someone who's, checking to make sure that Stitch is running every day or that your Airflow pipelines, check the dashboard. Yep, Airflow ran again, looks good. Like, that's not that interesting of a problem. And I think it's being sort of honest about what the role is and where you need people to come in before you actually hire someone who thinks they're coming in to figure out how to scale this Spark cluster to something huge, when in reality they're like just checking your Snowflake credits every day and being like, yeah, okay, we're still using it at the same rate that we need to use it. So I think that's kind of a big shift is you can get pretty far with the out of the box stuff now.
So for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
So I think one is the piece that we've talked about of how do you monitor pipelines, and not monitoring in a strict sort of DevOps sense, but monitor in knowing, again, when I have a question and I see something out of place, I can very quickly tie down whether or not it was because a date of changes, whether or not it was because some assumption that I made got invalidated, whether or not it was because a data pipeline didn't work or a pipeline ran in a way that was an ordering that was unexpected. All those sorts of things I think are super valuable and save analysts tons of time from actually having to dig through kind of the weeds of these problems. There's another place that I think we're starting to see some movement, but we still sort of don't have a real solution for, which is a centralized modeling layer, essentially, that when you think about how data gets used around an organization, it's not consumed by one application. That as a business, I have a bunch of data. Typically, folks now can centralize that data into data lakes or warehouses, putting it all into S3 and putting Athena on top or Snowflake or whatever. But then you have to consume that, and say you want to kind of model like what is a customer. That's a problem, that's sort of a traditional BI type of problem. But most BI models are models that only operate within the BI application. And because data now is spread so much through an organization, the model of what a customer is something that needs to be centralized. It needs to be something that's available to engineers who are using APIs to pulling data out programmatically to define something in the product. It needs to be available to data scientists who are building models on top of that to forecast revenue or build in product recommendation systems. It needs to be available to an executive who's looking at a BI tool to understand how many new customers we have every day. Like all of these different applications require this kind of centralized definition of what is a customer. And a tool like dbt is kind of moving in the right direction, but there's still not a great way to kind of unify concepts within a data warehouse like that, and in a way that it can be consistent. So you end up, as someone consuming that data, having to rebuild a lot of these concepts in different ways, which ends up kind of creating all sorts of problems of what is a customer in one place isn't quite what's a customer in another. I don't think we've quite figured out that part of the layer. Like we have the warehouse layer. There's very robust applications that can sit on top of the warehouse, but they all kind of feed into the warehouse through different channels and through sort of different business definitions of what this data means. And without that centralized layer, you're always going to have some confusion over these different definitions.
Well, thank you very much for taking the time today to join me and discuss the work that you've been doing at Mode and your experiences of working with data engineers and trying to help bridge the divide between the engineers and the analysts. It's definitely a very useful conversation and something that everybody on data teams should be thinking about to make sure that they're providing good value to the business. So I appreciate your time, and I hope you enjoy the rest of your day.
Thanks, Tobias. Thanks for having me.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.